we're dealing with a histogram here, and we have frequency density on the left. And frequency density is calculated for each bar by taking the frequency and dividing by the width. It's a way of being able to draw things graphically where the widths are not equal and avoid things being misleading. So how do we get back to the frequency? Well, we just simply rearrange this formula. So the frequency is the frequency density times the width, and then I can work out all of these. So for example here, I could do 12 times a width of, this is going to be, so it's 5 to 10 here, so this is going to be 2.5, so it's 12 times 2.5, and that's going to be 30. So we've got 30 here. Here I'm going to have 26 times 2.5, and that's going to give me 52 plus 13, 65. Over here, okay, now I've got a nicer width. It's going to be 15 times 5. It's going to be 75. Here, I've again got a width of 5. It's going up to 12, so it's going to be 12 times 5, 60. And then finally, I've got this really large width, but it's only 1 in height, so it's going to be 1 times 20, which is 20. So I'm just going to underline the key frequencies we've got. It's going to be 30 plus 65 plus 75 plus 60 plus 20. Right, that gives me 110. That gives me 140. So I've got 110 plus 140, which is 250. Job done. The UK living wage is £7.85 per hour. The newspaper states that 1/5 of workers earn less than this. Does Omar's survey support the statement in the newspaper? Okay, let's have a look. This is going to be a bit trickier now. So we're interested in finding all the people that are less than £7.85. So it's going to be these people here, which is my 30. Plus, now I'm interested in a very small little segment. This is maybe not to scale, but I'm interested in finding out what this little bit is here. And here is 7.5, so it's going to be the width, is going to be the difference between 7.85 and 7.5, 0.35. And then I'm going to multiply that by the height, 26. I'm just going to say that again because I'm not sure how clear it was. I'm interested in the total number of people less than 7.85, so the frequency is such. So I need to find the area of this section here, because remember, that's how we find the frequency, by doing frequency density times width. So I've got my 30 from before, okay, for everyone less than 7.5. I did that calculation before, 12 times 2.5, so I've just taken that straight away. And then I've got my width, which is the, I want to go up to 7.85. I'm at 7.5, so it's going to be 0.35 is my little width here. I multiply that by the frequency density, 26 again, and that will allow me to work out the total frequency. So 30 plus 0.35 multiplied by 26, 39.1. Now, obviously, we can't have 0.1 of a person, but like this is, you know, we're making estimates. Really, that's what we're doing with the histogram. So, is that 1/5 of the workers? Well, 39.1 divided by 250. Is actually 0.1564. And this is not equal to 0.2, which is what 1/5 is. So No, I'm just going to, I've run out of space, so no, it does not support the statement, but that should be sufficient. Explain why calculations in B part 1 may not give the exact numbers of workers earning less than the living wage. Because we're using grouped frequency, we are using grouped frequency. What do I mean by that? I just mean, if somebody was earning £21, they'd be in this group here, but if they were earning £39, they'd also be in the group. And you don't really know how it's distributed. You sort of assume that it's uniformly distributed, but it might not be. So that's what makes it approximate. I think that's enough for the 1 mark. Words to that effect. Okay, Omar uses this table to record the ages of the people in a survey. Comment on one problem with it. Well, looking at it, where do you put the data if somebody was 40 years old? You'd put it in this one and you'd put it in this one. So that is not good. And one problem is that there is overlap. There is overlap in the groups. You should never have that. Done.